Hello viewers, welcome back to video tutorial on AgentGrid. This is the fourth video in this tutorial series where we are discussing different patterns of agents using AgentGrid. In our earlier video, we have discussed several three different patterns. One is a sequential pattern, conditional pattern, and parallel pattern. In this video, we'll be discussing about a router pattern. So to know more about AgentGrid and AgentGrid SDK documentation, you can click on the links provided here. And to know more about any agentic patterns, so the links provided here will help you. So what is this router agentic pattern? So while explaining the router agentic pattern, we are taking some special use cases. In this tutorial, we'll be taking the help of help desk ticket routing. So these details are already explained in the previous videos. I request you to check the previous videos. So the help desk ticket routing with the router pattern. So here in this pattern, we have a specialized pattern known as a router, which is a central agent, which orchestrates a set of specialized worker agents. And in this particular help desk case, we have several worker agents like account agent, billing agent, compliance agent, customer experience agent, security agent, and tech agent, which is orchestrated by the router agent. And the final outcomes of any of these worker agents will be synthesized by the synthesizer agent. So in our previous parallel pattern, we kept the muxers as well, where the number of muxing, like the number of fan in, was controlled by one particular variable. But here, as you can see, the router agent can route your request to any of this, so we cannot fix the n here. So how to make it dynamic is what we'll be learning in this video as well. So yeah, the router agent analyzes the user request and dispatch it to one or more domain specific experts. A specialized agent like account, billing, tech, security, compliance, and customer experience process the request in parallel, and the synthesizer final agent will aggregate the output using muxer and provides the final response. So we have a router agent. It acts like a dispatcher and or a classifier, analyzes the request, dynamically selects appropriate specialized agents for processing. And this is the code here. I have kept open all the files. I'll explain one by one. And the tech next tech agent, account agent, the worker agents, they act as a worker. So they have a very similar code, so there is no changes. If I explain one, rest all things can be understood. Only changes might be with respect to the system message. Rest all remains entirely same. And the synthesizer agent, which basically acts like a aggregator, collects the result from all active workers via muxer to form a cohesive final reply. So let me start with the maybe one worker agent. So let me take a worker agent, a tech agent. So you have a signature here, DSPy signature. You are a helpful help desk tech agent. Input format a string containing original request, so whatever the user has sent the input, right? So that will be available, and the output of a router. So this is a router's JSON output, and you must return only valid JSON that conforms to Pydantic model tech output with the schema. So this is the schema that we are expecting from this particular agent, and that's what the DSPy will take care of it. So we have a text, which is a formatted input containing original user request and router output, and the tech output, which contains the JSON what we have here. Basically it will send a domain summary, hardware related, software related kind of things, and who has actions, so who has to take the action, so related things will be available here. So it's always good to give some a few short learnings. You better train your expert by giving some examples, so that the signature, the module will understand better how to handle and how to format your output. So right now I'm not doing that, so you can go ahead and do that. So we have a tech module which based on the base class of a DSPy module, which uses the DSPy chain of thought using the signature. So the same the signature or the same the system message, whatever you are seeing here, we have put it in our registration file as well. That with that JSON files system message, we are just updating the text signatures right now. This system message and the doc string as well as the system message that comes is almost same. there's no difference at all. So this is the content of that system message, default system message. So the DSPy module has a forward function which does the inference. Tech expert is the chain of thought object, and we are passing a input known as the text. So we have a payload processor. Basically, it's the input processing. So whenever we get an agent task object, so we'll just parse it to get the input needed by the rest of the code. So we are passing input text, communication, model name, session ID, and we have a context model context manager, which will take care of managing providing you the context of a model that has been chosen. And that model context will be set as a global for a DSPy. So DSPy, whenever it does the inference, it uses that particular model context. So here we have explained this AOS DSPy LM class already. So you can use it for inferencing the blocks which are available in AI OS, and also the third party like OpenAI or Gemini models. So we have a content parser, which is like basically pass the input, like whatever the input has come to this particular tech agent, right? So it will just pass that. Basically, it will try to give you the original user request and the router's output JSON. So it will try to give that value. That's it. And also it will allow you to take a default return values. If I'll explain what is a get minimal output. So here a sample agent, which is adhering to the similar class structure which is available here, the sample class. So we are taking a default message from the JSON file, and context and subject. So context basically carries all the context required or any internal communication things required, right? So you have this in wrapped in the self.context, and any registration related things are available in the self.subject. So I'm having a file agentic.conf.yml. So I'll just show you the content of that for this particular use case. So basically we are right now using as a help desk, and it basically tells you for which agent who is the next agent. That's it. And only thing is a router agent, it has to take a decision, and the final agent, synthesizer agent, is not having any next agent. So instead of hard coding the code, we have just kept it in the YAML file. So these are already explained in the previous videos as well. We have a AOS DSPy, and we have a module which is a tech module that was described here, a tech module, and we have a payload processor, model context, and a content parser. We have some other functions which will be called by our on data function. So you have an input text and communication type and model. So as soon as the agent task comes, we are sending it to a prepare input function, which will pass the input, and it will give you these 4 values. In that, these are this will go again for further parsing, because this contains a user's original request as well as the router's output as well. So it will basically parse that, and it will provide you the user's original request and a router output. And since this is a tech worker, so to do the tech job, we are calling this executor worker, where we are passing the input tags, original request, and router output as well. So let us just check the execute worker. So execute worker, so if it is not a tech agent, since I know that this is a tech agent, if it is, so let's say by mistake the tech agent has been called, though tech agent is not in the selected agent, I am returning some minimal output. So that minimal output is what this particular JSON is: domain tech not applicable, hardware related, false. So basically a default return statements. And if tech is selected, definitely it will come here, and I will do a module dot forward by selecting the proper chosen model. Model name is coming here as an parameter. You can send the model name in your input message as well. You can select it, or else the DSPy will select randomly. So the tech output will be here. So result.tech output, because in our module we have told like we require a tech output, and input is a text keyword. So from that I'm extracting a tech output, and that I am passing as a JSON. So yeah, basically I'm doing JSON loads, because this is a JSON encrypted content. So if it is a string, I'll do a JSON load. If it is not, it is already a JSON passed content, so I'll just pass the output. So this will be passed this will be passed back to the whomsoever has called with this three communication patterns. And this holds good for other agents as well. So the code looks very similar. There is no difference at all, because they do the one single job, and they have a system instruction might vary from the for each and every agents. So the interesting things are happening at the first two agents, where router agent and synthesizer agent. So let me go to the router agent code base. So in the router agent, so again you have a specific system message is given here. You are a router agent. Your job is to inspect the incoming user request, plain text, and decide which of the available agents should handle the request. Agents available are, these are the agents available, and you must return only valid JSON, no extra commentary, that conforms to the pedantic model output router output with this schema. So this is the output that we are expecting from the this particular router agent. So it basically says whether tech agent is yes or no, billing agent yes or no, kind of a output will come out of this. And selected agent is an array of strings. So basically if any agent is selected, right, so that value it has to have those selected agents. This is very important field for us in rest of the process. And we are giving some examples here, and giving examples is always a good way, so that it's like a few short learning, so it will try to better your output. So yeah, this is the text input, selected agents, reasoning, and confidence. So these all are outputs that I am expecting from this particular signature. And we have a module which has a DSPy chain of thought, and with a router signature, what we have seen here. And these are like agent payload processor, parsing the input, model context, and parsing the actual input. So you have a selected agent, reasoning, and confidence. So whatever the output we get, right, so it can be a it is a like a JSON here, and from that, if it is not a JSON, what I have to do, if it is a JSON, what I have to do. So that's what this particular content parser will do. So if it is a str, then it has to do JSON load. If it is not a str, then it might be an already object, so it will return simply the val. So from here again, I am just formatting the output to selected agent, reasoning, and confidence. So this is what the router agent content parser will do. So this initializations remains same, so there is no changes. So now we are in very interesting SDK, which is we are using right now, agent search SDK. So if you have seen our codes, we have three different modules here. One is agent LLM and agent SDK. Agent SDK is for housekeeping or integrating ourselves with the AgentGrid platform. Agent LLM is for integrating or doing a communication pass on between any of the LLM models. And we have a third module, which is the agent search. So that's what we are using in our router here. Yes, so basically let's say you have several agents registered, and you want to choose the you want to search any router of choice you want. Like say this particular agent wants to take a job of a router, then we can search any router agents are there for this help desk kind of a job. So for that, we can use a known agents class. So known agent, you have to send a default compact false. So this, for this class, I'm adding a query metadata subject search tag as a help desk. So this is basically comes from the registration file. So in the registration file, we have a metadata and we have a search tags. So any agent which are registered with the help desk, right? So from that, I'm trying to query all the agents which are a help desk category. So that's what this known agents will provide me. So any agent with metadata.subject search tag, it has a help desk, right? All those agents will be in the known agents. So that's what I'm knowing it as a all agent IDs here in the help desk category. So next, from this agent, let's say there might be several agents. You have a router agent, synthesizer agent, help desk synthesizer agent, help desk router agent, help desk tech agent, help desk billing agent. So several agents are there, right? In that agent, I want to choose one particular agent for my task. So there, again we are going to take the help of LLM here. So the agent selector is a class, so I'll just instantiate it, and I'm registering a new selector here with the name of a default, and I'm giving an agent which is that LLM I need to choose. So this LLM could be a third-party LLM, or it could be a deployed in our AIOS. So I want to give an agent selector LLM, so which is in our current context, I'm choosing agent selector LLM as Qwen 3 1.7 LLM block. So this is deployed in AIOS, so I'm choosing that LLM itself. Yeah. So which LLM you want? So I'm using a Qwen 3 1.7 LLM, which is deployed in AIOS. And then these are some inference server IDs. These are required by the agent selector, which we'll provide, or whomsoever onboards the AIOS and agent SDK, right? So they can provide this inference server registry URL, blocks DB URL. So what is blocks DB URL? Basically, whenever you onboard any AI in our AIOS, so everything we call it as blocks, and we need to provide those block DB URL, so that whichever you are giving here, right, whether it is available or not, where it is deployed, all those details are needed by this agent search selector. So this block DB URL is also we need to provide. And from there I'm using this particular function, search from objects. I'm using the default that I have. I'm asked, like, you can register multiple selectors. So in that, I'm choosing a default one because this was the default selector. So I'm giving a name default. If no name is given, then again it goes to default only. Here also, if you're not giving any name, right, so by default the name is default. And known, you have to provide all the arrays of agents that you have. That's what I will get from known agents, list all. So it will provide you an object, all the available agents object it will provide. And then we are passing a query for routing task, help desk related. So with this query, what does LLM does is it will identify which router agent can use this particular, can do this particular task, because I am saying a routing task and a help desk related. So it has all the help desk related agents right now, and from that it will choose one particular agent which matches the user request. Here I'm saying a routing, so it has to select the routing agent. If say for tech task in help desk related, if I give like that, it will basically select the tech agent. But right now, since this is a code of a router agent, I am saying I need a routing task. So it will print that routing agent. If sometime, let's say for a query it is not working, then you need to basically fine tune your system message, because this block requires whatever the block that we are selecting here, right, it requires a proper system message. Right now the system message is curated and kept. If in case output is not according to your taste, then you can modify it. So next, this is the one new thing that we would be learning in this particular video, dynamic selection logic. So basically, a logic of this router agent is getting dynamically assigned. So this is going to be a router agent only when this particular piece of code runs. So next in on data, so as soon as a new task has come, it will try to extract a text from it, because it is a user input. As this is a router agent, it is a customer facing, so it will get the input text from the customer, and then we are passing it to an executor worker class, where this text will be sent. A random session ID is generated for the LLM, because I don't want to store this. I don't want to keep on creating the history, so I'm just generating a random session ID, and the same LLM is chosen, the like Qwen 3 1.7 B, that agent model is there, right? So that model is only chosen with the different session ID, and it will execute this particular DS by signature and module. And once it is done, it will return us the result, and from that result I am just passing the output, and from that I am trying to get the router output. So the router output will have selected agent, or some 2-3 keywords will be available from that parsing: selected agent, reasoning, confidence. And I'm checking now how many selected agents are there, and these are the selected agents. and if there is no selected agents, is not a list or something, I'm just warning unexpected type of selected agents defaulting to empty list. So this is what default value will be. And the first thing is I need to inform to the next agent. In our case, these are the sub agents and the final synthesizer agent. So router agent has to pass one communication to synthesizer agent that, hey, for this particular task I have chosen 2 or 3 or 4 sub agents, and you just have to wait for their output to come, or else you don't synthesize it. Wait until all the 4 output comes. If it has selected 4, if it has selected 3, you have to wait for 3 outputs. So this communication the router agent has to pass on to synthesizer agent. So that's what this piece of code will do now. Let's say we have got like selected agents to be 2 agents. Then as that is the array, so length of that will give basically mux size as 2. And now I'm creating I have one function which will provide me a JSON data that I can pass on to the synthesizer agent. So its next agent is a synthesizer agent, and in the prepared synthesizer packet, you have a mux size and session ID, model name, original user request, router output, communication type. So these are a few keys we'll be passing on to the synthesizer agent. So synthesizer agent basically it takes this key, and if this key is available, it will do something. Basically muxer will take this key and it will try to configure the n value in it. So this is one important key that we are passing to the synthesizer agent now from the router agent. And once the communication is passed, I don't have to wait for the output to come from the communication agent. So I'll just quickly do the next thing. So here route to a specialized agent. So I have a specialized agent, right? Like once selected agents are there, let's say it has selected 2 agents, it has to pass that information to 2 agents. So this particular piece of 2 lines of code will do that task. So basically I need to send the user original request and output of the router's decision, and then I will be passing it on to this particular function, route to specialized agents. So in route to specialized agent, basically I'll take that what all agents are there, I'll try to take each agent IDs, and for them I'll create a text key, and rest all the remains same, like model ID, agent, session ID remains same. So this text is very important. This text is what this particular piece of this line. So original user request and output of router will be available, and no other any other extra further data will be available. We'll be sending it to those agents via these 3 protocols. So the router agent is passing the output, and it is returning with skip equal to true, because it doesn't have to do anything now. So skip equal to true, and now the next agents will try to process those outputs, and it will pass on the output to a synthesizer agent. So let's go to the synthesizer agent. So I have a special class here, a muxer. So this muxer is somewhat little bit different from the previous muxer we saw in the third video, where the n was a main thing, where the muxer when muxer class is instantiating, the n was taking a value that was supposed to help us in closing the muxer's loop. But here n is of no use for me, because the router agent can dynamically select number of different agents. So I don't want n here, but I have kept it because it was available in the previous example as well. So now I have an add function here, and before that I have 3 variables: self.packet, self.expected count, and self.received count. So expected count is how much, basically it is a n value, and received count is basically how many inputs I have received. Let's say n is equal to 4, it has to go up to 4, and as soon as it goes 4 or beyond, right? So basically we'll be breaking the loop, and we'll be passing the input to the actual synthesizer loop on data function. So here, as you can see, the key has to be passed. Key is very important, and a task. If key is not available, I'm calling it a session ID. So if this session ID is not available, I'm creating a variable, and I'm initializing this expected counts, which is a n by default to 1 and received count to 0, and exclude key. So any data input it receives, right? So if these keys are there, I'm just asking it to not dump this in self packets. Let's say you have original user request, let's say router agent. Yeah, so the router agent, when it's sending mux size, it might have original user request, router agent, router output. All these values will be put into this self.packets, and this mux size, model name, communication, and session ID will not be dumped. So this packet has some extra data which was sent during the router's call. So if mux size is there, it will exclude, rest all it will exclude, only things it will keeps which are not in this particular set. Then mux size is a special key. As I told, mux size, it will check if the mux size is available, then expected count, it will try to set up the value which is size of n, and if it is not there, it will simply increment the received count to +1, so that received count is incremented. And if received count is greater than or equal to self expected count, then it has to return the final task. So in the final task, I am taking the copy of this particular input, the task, and from the packets, whatever the self packet is there, right, the history of packets, so from that I'll just put it into aggregated task.job data, and then I'm deleting and cleaning up all the self variables that I have created, and I'm passing this aggregated task. So basically I'm taking a copy of task agent task variable here. Agent task variable is copied, and I'm just dumping all the previous history of data. And once synthesizer agent aggregates all the data, right, so it will pass on that to the on data function. So until it gets all the 4 items, it will not pass on. Only once it gets all the 4 items, it will pass on to the synthesizer agent. And in our synthesizer signature, so it is your helpless synthesizer agent, JSON object containing output from all the specialized agents like account billing, compliance, security, tech agent, customer experience agent. So original request, user request will be there, router agent will be there. Your job is to aggregate finding from the each expert agent, resolve any contradiction between agent recommendations, and formulate a single cohesive empathetic final response for the user, and return only valid JSON. So I'm giving a JSON structure that I want, and the rest remains the same. So as soon as Muxer provides a data to on data function, it will parse it, and aggregated data is copied, and it will be given to the execute worker, and executed worker does the inference with the help of the LLM that we have passed with the context by setting the context in the DSPy module, and that output will be passed on to the return back to the user. So now so let's try to run this. So we have our all.bash file which will take care of doing these 4 activities, basically removing of an agent if it's already running, unregister, register, build the Docker, and deploy the agents. So let's do this. So it is not trying to remove if it is any agents are available, waiting for 30 seconds because the removing of pods will take time. So it is sleeping for 30 seconds. So now it is building the dockers and pushing the dockers to the registry, and once it does for all the 6 to 8 agents, then it goes for a unregistration and registration and deploying the agents. Yes, it has deployed all the agents. So let us look into the agent. Yeah, they are running now 8 to 10 seconds back. So all are running. So executor pods are running, and instance pods are running. Executor has 3 by 3. One is a executor, one is a, we have a basically in 3 by 3 you have a executor which will help in rate limiting config, load balancing, auto scaling using policies, and a scouter pod which is responsible for scouting jobs in job exchange. Right now we have not shown any example, we'll be showing using this scouter later. And the other one is a redis and for communication. And here in our instance we have 2 by 2, one is a redis and one is a agent core, which is this particular codes whatever we have shown, right? So those particular codes will run in it. So let us do an inference request. So before the inference request, so I'm just showing, okay, let me take this. My internet keeps dropping and your system overcharged me this month and not happy with your service. So let us see what the inference request will, how it will process. Okay, so this is the input and this is the output. Synthesizer final response: thank you for reaching out, we understand your internet connection is dropping and you are not happy with the service. Regarding overcharging, we will investigate, resolve both the issues as soon as possible. Please allow up to 48 hours in response. We appreciate your patience. So internal summary: the user is dissatisfied with both the service and billing charges. The tech agent identified the internet issue, billing agent detected a overcharge, and CX agent addressed the customer's dissatisfaction. So because we have told we are not happy with the service, so it has selected basically three agents. One is tech, billing, and a CX agent, and their different outputs are here, and priorities are also available here. And so let us try to remove, let me try to remove this, and let me save it, and let me try to rerun again. Okay, so now you can see, right, I'm not seeing a CX agent because I'm not given anything related to the my experience or a custom dissatisfaction is not there. So only it has passed it to tech agent and a billing agent. So that's it. So only two agents are handled for this particular message. So right now I'm not given any few short examples, and I have not done extensive training or optimizations for the DSPy, so that you can do it and maybe help this to better the code. So yeah, now the agents are running. So to remove the agents, we have remove agent.sh. So it will basically loop through all the agents and it will try to remove all the agents. So let me remove the agents. So agents are terminating one by one now. And so basically we have seen a router pattern which is ideal for handling multifaceted user requests by leveraging AgentGrid SDK and Muxer logic, where the Muxer was dynamically configurable, where the router agent was configuring the synthesizer's Muxer size, and the system ensures that complex tickets are handled by right set of experts and synthesized into a coherent user experience. So this is what we have seen in this particular example. So that's it for this video. Thanks for watching, and keep supporting us.